Now we're taking a dive into cluster modeling, which is kind of like the second subpart, and where the first 4 parts here are cutting down the scenarios. And then cluster modeling and replicating liabilities are the 2 that cut out a number of policies to only keep the policies that are the most representative of the full set. And that way your runtime can go cut down and you can do your projections. Now for these 2, the efforts required is really high, but it has a really high payoff. And they both have the same limitation right here that they discuss right here, where bias is concerned. So let's jump into cluster modeling a little bit. So cluster modeling, we have a little sample that I have of 5 policies. And the goal is to find which of these policies are the most representative, so we could cut down the runtime. And for the very beginning of cluster modeling, you get to determine your segments. And I'm going to go a little bit more into cluster modeling in a different video, but for this case I'm just going to be really general and say, let's say our age band is a segment, and we want anyone over 65 to be in one band, and then anyone below 65 in another. So policies 1, 2, and 3 would be in one segment, and policies 4 and 5 would be in another. And let's say I wanted only one policy to be represented in each segment. And so that means we need to cut either 4 or 5, and then we need to cut 2 policies of 1, 2, and 3. And in this case, the goal, it gets a little bit mathematical, which again I want to cover in a different video, but it has to be determined by the size and the importance of the policy. And so you'll see here that policy 1 has a much higher face amount than the other 2, and then this one has a much higher face amount than policy 5. So that will play into the importance, but what also plays into the importance is the distance between the other policies. And so on the variables that the actuary determines that they want for the distance. So let's say the actuary decides they want reserve and profits to be 2 different distance variables to be used for the importance factor. And there's a little bit of calculation involved. It's like the difference, and then you do like the sum of squares of it. And you'll see here that the reserves is really distant from policy 2. But then again, policy 2 is really different in the reserves from policy 1 and 3. And so that's going to really increase the difference, the distance there. And that might actually play into the total importance of policy 2, thus maybe keeping policy 2. So there's a whole algorithm involved, and then it'll trim down on the number of policies, and then you only have 2 policies that you project instead of 5. So that's the sort of idea. The actuary determines how many segments that are taking place, what type of segments, and they also determine what gets to play for the distance variables. And then that all gets into the algorithm. Once you put in all those inputs, it comes up in the output, and you want to test. You want to be really careful that your metrics, such as your CTEs and your means, they all remain somewhat the same with minimal error in comparison with using the total data set. This is probably one that has the most content of reading on the SOA exam. It is also I copied this from the textbook or from the reading, that cluster modeling is the most developed technique of all the techniques tested in this study. So out of all of these techniques right here, it is the most used. It is in the industry. Again, there's bias. That's a concern because the actuary is the one that decided on their segments. They decided what to use for these outputs for the distance. But again, it has pretty minimal error overall, and it really significantly cuts down the runtime. So there you go, there's cluster modeling.